look at the objective. I can show the quotient of a whole number and a fraction by showing the connection between models and the multiplication of fractions using tape diagrams or fraction bars. As we learned in the previous lesson, in lesson 1, we learned that a quotient is the term or vocabulary word for the answer to a division problem. In lesson 1, we talked about dividing whole numbers and fractions, and we're going to continue that with this lesson as well. The only difference is this time we're going to divide the whole number by a fraction, and we're going to be doing that showing the connection between models and multiplication. In this lesson, you're going to learn that you can use a variety of different models or KCF, known as keep, change, flip, to help you find the quotients. Let's look at some examples that are going to help us meet our objective for today. In our first example, we are given a graph that has an original question. We need to write in a corresponding division expression, write in a multiplication expression, and write an equation showing the equivalence of the two. But what is an expression? An expression is a mathematical statement that doesn't have an equal sign. For example, 6 plus 6, or 8 divided by 1/5, or 9 minus 2, and so on. All of these examples are lacking an equal sign. They show math operations, they're just not showing an equal sign. And this is what we call an expression. And we can't talk about expressions without talking about an equation. An equation is a math statement that shows two expressions and how they are equivalent. For example, 2 plus 2 equals 4. 2 plus 2 is a math expression. And 4 by itself is also a math expression. But when you put them together with an equal sign, it becomes an equation. You can also write an equation using multiplication and division and showing how they are equivalent. Let's go ahead and head back to our problem. Now, remember, in the first column, we're going to be writing a division expression. In the second, multiplication. And in the last column, we're going to be showing how division and multiplication are equivalent between the two expressions that we've created. In the first question, we have, how many 1/2 miles are in 12 miles? Well, what am I doing here? I was given 12 miles, and I want to know how many times 1/2 can fit into the total 12 miles. That means that my dividend is going to be 12 and my divisor is 1/2. So to set up my division expression, it will be 12 divided by 1/2. To help us write a corresponding multiplication expression, we're going to use KCF, keep, change, flip. We're going to keep the first fraction, or in this case a whole number, change our division symbol to multiplication, and flip that fraction. So it will be 12 times 2 over 1. As you notice, anything over 1 can be turned into a whole number. So we can get rid of the 1 and just write 12 times 2. Finally, we need to write an equation showing the equivalence of the two expressions. Well, the first expression that we created was 12 divided by 1/2. And if we solve 12 divided by 1/2, we will get the same answer as if we were to multiply 12 times 2. And now we have both expressions showing how they are equivalent. Let's take a look at another example. Let's look at number 5. How many 1/5 are in 7 wholes? Again, this question is asking us, if we start with 7, how many 1/5 can we get out of the 7? Well, that means that we're dividing 7 by 1/5. Similar to our first example, we're going to use KCF to help us. We're going to keep that 7, and we're going to change our division symbol to multiplication. Instead of 1/5, now we're going to have 5 over 1. Remember, anything over 1 can be turned into a whole number. So instead of 5 over 1, we can take that and make it just 5. So 7 divided by 1/5 is equal or equivalent to 7 times 5. The two problems that we just looked at in the first example are what we call measurement division. In measurement division, the divisor names the size or the measure of the group or unit, and the quotient represents the number of groups for the unit. A measurement division problem can often be solved by thinking, how many blanks are in blank? Let's take a look at a different type of example. Let's look at example number 2. Now remember, while we're looking at example 2, I want us to think about the question, how many blank are in blank? In example 2, we have Molly has 9 cups of flour If this is 3/4 of the number she needs to make bread, how many cups do she need? Let's go ahead and annotate what we know. We know that we have 9 cups of flour. And in that 9 cups of flour, we need 3/4 to make bread. And the question wants us to answer how many cups does she need. In order to solve this measurement division problem, we're going to use a tape diagram. But first, let's go ahead and write our division problem. In this instance, we're going to read this as 9 is 3/4 groups of what size? Meaning that our division problem will be 9 divided by 3/4. I'm going to construct my tape diagram by reading it backwards, and I'm going to draw the tape diagram and label the unknown. I know that I have a whole piece here. I'm going to partition my tape diagram into 4 parts based on my denominator. Now the tape diagram box is equal to out of 4. According to my numerator, I'm going to shade in 3 of the boxes. And these 3 boxes are equal to 9. So 9 divided by 3 gives me 3, which means that each of the 3 shaded boxes are equal to 3 units. If those are equal to 3 units, this last box that is not shaded in is also equal to 3 units. If I was to take the total of all of the 4 boxes, I would get the total of 12, meaning that 9 divided by 3/4 is equal to 12 units, or 12 cups of flour. In this problem, we knew that 9 is 3/4 of something. So like multiplication, we can say 9 equals 3/4 times some number. To find out what goes in the blank, we divided 9 divided by 3/4. Well, this isn't the only way that we can solve measurement division problems. But let's review our notes to make sure that we really know what measurement division is. Dividing whole numbers by fractions can also seem like measurement division. Now, measurement division is when you know how many are in the group, you have to find the number of groups. I want you to add to your notes the big takeaway questions, especially centered around measurement division. The question includes, how many blank are in blank? One of my favorite ways to solve measurement division problems is using my tape diagrams. At the bottom of your notes is an example of how to solve using a tape diagram model. But not only can you solve with tape diagrams, you can also use keep, change, flip for this process also. You should already have the notes for keep, change, flip. So go ahead and get those out, and we're going to look back at example 2. Instead of this time using tape diagram model, we're going to use keep, change, flip to solve 9 divided by 3/4. We want to know if we get the same answer, and that will show us the relationship between multiplication and division. Remember, we're going to set up our problem, and if you notice, the 9 is a whole number. Just like we did before, in order to turn a whole number into a fraction, we just need to put it on top of 1. So now we have 9 over 1. We're going to switch our division sign into multiplication, and we're going to flip from 3/4 to 4/3. Now multiply straight across. Get your calculator out if you haven't had it this whole entire time. Go ahead and solve this. What is 9 times 4? You should get 36. And 1 times 3 gets us 3. Now if you notice here, we need to simplify. But instead of simplifying by dividing, we're going to use long division. How many times can 3 go into 36? 3 can go into 3 one time, because 1 times 3 is 3. And we're going to bring down the 6. And 3 can go into 6 2 times. 2 times 3 is 6. And 6 minus 6 is 0. So we know that if we were to take 36/3 and reduce it, we will get the solution or the quotient of 12, which is the same answer as that we gotten in the previous example. All right, guys, go ahead and complete that must do and should do, and review this if you have any questions.